Whoops. Hi everyone, just about dropped my computer. Here is a little screencast to explain the answers to some questions from our textbook that I was asked for. So the first one is question 13 from exercise 9.06. We are asked or given the following expression: cosine pi over 2 take theta divided by the cosec of pi plus theta. And our job is to simplify this as much as possible. So I'll begin by looking at the numerator. And if I think for a minute about a right angle triangle, this could be an angle theta, and up in here would be the complementary angle pi over 2 take theta. Now let's go give the edges the names A, B and C. Think for a minute about the angle pi over 2 take theta. That's what we're dealing with. And the cosine of this angle would be the adjacent divided by the hypotenuse. Now, is there an easier way to get A divided by C? Well, yes, there is. If I focus on this angle, then the sine of theta would be the same ratio of A divided by C. So that's our first step. In simplifying, we will make the numerator sine of theta, using the old idea that sine of an angle, as long as it's an acute angle, equals the cosine of the complement. Now it works the other way around as well. You could say the sine of the complement equals the cosine of the original theta. So that's a nice little one to keep in the back of your head. Now, what about cosec of pi plus theta? Well, I will first write this as, what is cosec? Cosec is the reciprocal of sine, and it'll still be pi plus theta. So instead of cosec, I have 1 divided by sine. Now, the divide by a reciprocal is clumsy, so I have sine theta multiplied by the sine of pi plus theta. For this one, I'm going to need to use my Cartesian coordinates, the 4 quadrants. So 0 would be here, pi would be here. Pi plus theta gives me an angle somewhere down here in the 3rd quadrant. And in that quadrant, now, pi would be to there, and the little extra bit would be moving by theta. So altogether at that point, I have travelled an angle of pi plus theta from the start. Now, back in that quadrant, remember the old all stations to central. The tan ratio is positive in that quadrant, so the sine ratio would be negative. So my first one here would be sine theta multiplied by the negative sine, and the reference angle is theta. The reference angle, remember, is the angle between the horizontal axis and the point that you're interested in. That little angle that I've highlighted in yellow is theta. So I now have, I can simplify this to be negative sine squared theta. I think that's where I'm going to stop. I could use the Pythagorean identity. I could write 1 minus cos squared, or it would be negative 1 multiplied by 1 minus cos squared theta. I'm thinking of this as negative 1 multiplied by sine squared. But does that make it any better? Well, that's cosine squared theta minus 1. Is it really easier? I don't think so. I think it's best if I stop here and just say negative sine squared theta. That would be my preference. Cos squared minus 1 is really not easier, I don't think. So that's that question. That one's good, a lovely question. Thank you for the person who asked that question. Because this is going on YouTube, I won't say who you are by name. Now, the next question was number 6. The clue we had in this one was the tan of x equals 1/2. We had another bit of information, and that was that x had to be somewhere between pi and 3 pi over 2. Now you might be tempted to reach for the calculator and go the inverse tan of 0.5, and you'll get some horrible number. We're not going to do that. We're going to draw the xy axis. We're going to mark a line down here somewhere, because remember, this is 0, this is pi, that one up there is pi over 2 radians, and this one is 3 pi over 2 radians. So we have an angle x. X goes all the way around to there. That's x, and it's definitely between pi and 3 pi over 2 as required. There would be a reference angle in here, wouldn't there? Yes, there would. And the reference angle in there, I might even extend that. The reference angle could be used to form a little auxiliary triangle. Nice. Now, whatever the tan of x equals, it's going to have to match up with the edges of that auxiliary triangle. It says tan is 1/2. Tan is opposite over adjacent. The opposite side of 1, the adjacent side of 2. But that's a little odd, because aren't distances to the left of origin negative numbers? And aren't distances below the origin negative numbers? Now, does that still match with the clue that the tan of x equals 1/2? Yes, it does, because a -1 divided by a -2 comes out, of course, to be the same as positive 1/2. So that is the edges of this little auxiliary triangle for my large angle x in the third quadrant. Pythagoras will tell me the hypotenuse of this little... Why did I not colour that one yellow as well? That's silly. So Pythagoras will give me, well, what's -2 squared? 4. What's -1 squared? 1. 4 plus 1 is 5. And remember, we always take that to be the positive root. The hypotenuse of these little things, it's a little bit like the radius of a circle. I've never heard of a circle with a negative radius. Wouldn't make sense. So the hypotenuse of these things are always positive numbers. Now that's the information that was given, and we've done a lot with that. The question said find the sine of x. Okay, well there were 3 steps, there were 3 parts. The first part, find the sine of x. Well, I'm going to use the auxiliary triangle. The opposite is -1. The hypotenuse, so opposite over hypotenuse is sine, is √5. That works. I probably should rationalise the denominator because it's just good form. So I have -√5 over 5 as the sine of this unknown angle x. I didn't even need to find the angle. Finding the angle would be problematic. This could be a technology-free question. The second one said find secant x. So we need to remember that secant is 1 divided by cosine of x. 1 divided by, now the cosine of this one adjacent on hypotenuse, -2 on √5, -2 on √5. I'll put some brackets to make that abundantly clear. And now dividing by a reciprocal, that will be √5 over 2, and I'll just drop the negative sign at the front there. That's the secant of the angle x. And finally, I think it was the cosecant of the angle x. Well, you'll know this one is the reciprocal of sine. Didn't we have sine earlier? We did. Sine was -1 over √5. -1 over √5. And so that's going to be √5 over 1. That's √5, and it was negative, wasn't it? So there's the answer. Those bits were the simple bits. The hard bit in this one was taking the original clue about tan of x equaling 1/2 and the fact that it was in the third quadrant to complete the diagram and draw in this little yellow thing which we refer to as the auxiliary triangle. So that's two nice trigonometry questions done. I'll be posting this one in the homework help playlist. Thanks for watching.